morning. Welcome to this Startup Clinic, Build with AI, brought to you by HubHub and IBM. Before we kick it off, I would like to give the word to Daniel Dauchik, Digital Sales Automation Specialist at IBM, who's going to demystify some of the links to help us kick it off.
All right, thank you. Good morning, and I'll be very short. Just to say, I'm Michal's colleague, and I'm helping out on any, let's say, links or registration or working with IBM Cloud, our platform, or Watson AI as your contact. But of course, you can go to Michal after the session without any hesitation. I will post a link in the chat just after I finish speaking, where you will find a link to where to sign up for a program called With IBM. That program was discussed also on Tuesday in a panel discussion. If you were there, very inspiring thoughts. And you can use that program to sign up your startup to join IBM on IBM Cloud and get 120,000 credits in cloud for the whole year to build use services in IBM Cloud. There's over 700, and you get also some technical advice and hands-on, such as you will see now from Michal. So that's it from me, and over to the master of ceremony today.
Okay, so this is Build with AI and Demystifying AI practical session. Let me just minimize. All right, yeah. The agenda for today is just quick introduction. Then I will just focus on one of the part of AI areas, which is optimization. I think there is a lot of ABC courses and workshops about visual recognition and neural networks and the classical statistics and linear regression, logistic regression, but there is not much about optimization, and optimization is really, really important, and you can do a lot of things with some basic software from IBM. Also, I will just tell you a little bit about Watson Studio, which is our environment on IBM Cloud for playing with data and building some models. And then I will go through two optimization use cases, and then you will just get this practical point of view of what can be done with simple optimization models. All right, so just reminding you that as we are speaking about AI, IBM was contributing, from starting from 60s or 70s, because in the 60s we were building those translators, translating from English to Russian, and then those efforts they were stopped, and there were some milestones in AI, and then there were some winters in AI, and the most known milestones are like in 1995, Kasparov, and so this was the first computer playing chess with the grandmaster and winning with the grandmaster. And I would just say one sentence about this very important one, is that if you think about the influence, the impact that the AI is having on our world. So, for example, for the chess, this is really interesting because the number of grandmasters starting from 2000 really grew up. You can check this in statistics. I just give you this quick fact. And this was the AI playing chess. And the result was the number of grandmasters in the countries like Europe, India, everywhere, Africa. So that's, I think, there are a lot of, we talk a lot about impact of AI and the future impact of future AI solutions. However, the most known impact is that those people, those bright people, or those hardworking people that want to use it, They just use it and they are even better in what they do. So the second milestone was Watson playing Jeopardy. And this was really first time that some computer just got a question and was looking for the answer in the books, right? Like imagine computer searching through PDFs. So now this is normal. A lot of technology is doing this, also in IBM. But then in 2001, it was really some kind of breakthrough. And last but not least, 2019, we created a project debater. So this is a machine able to debate with you. And so you give your arguments, then the machine is listening and it is giving you the counter arguments. And it may convince you on some point. So here on the slide is Dan Zafrir. He's the best, the world champion in debating. There is such discipline. So apparently on 2019, project debater from IBM lost with them. However, it was really high level competition. And right now what we've got, so we are working on this technology. And right now some early adopters are utilizing API, project debater APIs. So I mean, they don't have this machine in their company, but they have access through APIs, and they also are NLP, I mean natural language processing engineers or scientists, and they exploring our technology. So just giving you some nice materials from IBM. So the first one is AI definition for the beginners, explaining everything, every basic concepts in AI, that every concepts that are important for business, right? Because we in IBM we are focused a lot on business. However, we've got the greater research, even more than Google or more than AWS. Our research is the biggest in terms of people, engineers, papers, and patents also. So we are focusing on research, but at the end of the day, this is business. Second link is very important. Maybe I will just even click it. Daniel, are you there? I wonder if my browser has opened. Can you?
Yes.
Oh, thank you.
Indeed.
Yeah. So you know, on this page you can check our approach to design when it comes to building any AI solutions, starting from simple solutions like chatbot, like some robotic process automation bot, some simple things, or simple classifier checking some state or a number of states, and ending on some complex solutions. So we got some experience in this, and we got this all together. And as you can see, there is ethics as a separate chapter. So that is very important part of it, of this. And we've got, you know, holistic approach to designing AI, and this is very different than designing your app on mobile phone. Very different. So I just encourage you to visit this page. And another things are IBM research. If you are like several years in AI or in machine learning or some building some stuff in the area, then I encourage you to visit our website from research. Oh, sorry, from research. And here is the collaborate button, so you can also, if you have built something you believe it's really of value, and you're looking for accelerating it or sharing with some entity like with us, then I encourage you to do this. And also you can read about this, for example, fluid intelligence. This is really interesting, because as for fluid intelligence, for example, we know all those neural networks learning, for example, about if this picture is a cat or is it not a cat. So for a computer, it requires like hundreds of pictures of cat and hundreds of pictures of not cat, which is really crazy, because our minds are learning in different way. If you show me the new animal that I don't know this animal, and you show me it on the picture, then I will just be immediately able to recognize if on another picture there is this animal or not, right? So this is fluid intelligence, more or less. But however, I encourage you, if you're advanced and you've got this interest, I encourage you to deep dive on this. It's really interesting. And also there is several tools for building AI, like AI fairness and AI fact sheets. Maybe I will just tell about them together. So those are open frameworks where if there is a bias, of if there is if the model, or if this agent, intelligent agent, is not fair in a way, then AI fairness lets you shows you the way to make this agent fair, more fair. In terms, I will give you just an example. Let's imagine you've got this algorithm, you've got this model for giving the loans in the bank or not, right? And then you see that the model is giving the loans, so is giving the money to young males under 35, and this is 100%, and it's not giving the money to women over 65, for example, right? And this is really clearly unfair, and we don't want to do this. We want to mitigate, to adjust a little bit some things, right? So that's a really great tool to read about this. And this is just a teaser. I'm showing you a lot of stuff, but this is super interesting. But each of those is like separate workshop. And last but not least, if you are interested in Watson and you're just building things, so here I will share with you after the workshop the page when you can go through why Watson, then see the solutions, some customers if you are interested, and then building how to build with Watson. And Watson is a huge brand in IBM, and it has a lot of different solutions, starting with huge solutions and ending on small services on IBM Cloud, where you can utilize it for free, basically. And I will show you today those free services. Okay, enough with those links. And now I'm going into optimization, because as I said, there is a lot of machine learning and visual recognition and NLP and everything, and people just forgot about optimization. This is really, really useful and super important. So there's more and more data, and often we use those machine learning models to see the data, to predict what is going to come, to understand what is going on, and then we are making those decisions, right? But then so we are having expertise on what's going on. We are having expertise on prediction, so what's going to happen, and then we make decisions based on our guts. And of course, intuition is super important. However, we can also utilize some tools in making decision process, and this is really important as you get to the business, to the functioning of the company or startup. And you can leverage the insights and data you got, and you can use mathematical optimization, right, to make a planning. And in IBM, we call it decision optimization. So if you search for IBM decision optimization, and Watson, then you will find the free tools where you can start this journey. So talking about analytics or the area of maybe not AI but analytics. So there are three. You may divide it in three areas. So the first one is descriptive, when you see what happened and you understand, you try to understand the trends, why you got this great quarter, or why you didn't have this great quarter, what happened to your customers, what they did exactly, and so on and so forth. The second area is predictive. So you just take one feature, for example, the income, right? And you, based on what happened, you predict the future income for your company. Or, for example, you just try to guess, you predict if some person is ill or not, based on the model trained with other people that were ill and were not ill, right? So that this is this kind of stuff. And prescriptive, and I'm going to talk about this one today, is what you will do. So you are planning for something, and this is decision optimization. And in my opinion, this is super important. So use cases for decision optimization are everywhere, like because when we do something in our everyday lives, is we've got those limitations, and we have to do trade-offs. Like there is, time is main resource that we are lacking, right? So today, after this workshop ends, you've got like 2 or 3 big things you can do, or if you are learning something, you can do only one thing. You have to choose. You can choose about some technical things, or maybe some sales things, or maybe you will just spend it for conversations with your clients, right? And those are choices that you make. You have to make this trade-off. So you can quantify this, and you can make a planning, even if with your activities from the personal level, and you can utilize decision optimization to this. And naming those cases that are worth building a model in decision optimization. And model is, I mean, that you create some simplified version of reality where you make some things. I will explain this in 5 minutes. But speaking about use cases, is like, for example, factory managers have to find the best sequence, right? You are a producer of the shampoo or a cookie or something else, and then you can move with those ingredients, and you can search for optimal mixture, right? Optimal in the cost sense, optimal in the taste sense, or the qualities perspective. Another case, companies need to optimize schedules, like there are workers. Of course, you are hiring a new person. It's best where this person will be doing everything, but this is, really, we all know this is a disaster, right? People need to focus on some things, and then you have several workers, and you need to split those roles among those workers. And you normally do this with your intuition, but you can use the planning, and then those workers will be happier, and you will be happier, and you will have a better result. Another thing, retailers need to optimize distribution, right? So we are all buying e-commerce right now in the COVID times. So, for example, this trade-off between having some products on the shelf, that somebody is buying it, you are selling the product, and another option is you just somebody is buying and you buying that product, and you are waiting as it comes to you and comes to the end client. So this is also a trade-off, right? So optimization is pretty much everywhere. Of course, you cannot build good models everywhere. However, you can at least try do this with your data science guy. There are personal choices, there are company choices, and there's a lot of use cases there. And now I'm just going to the optimization itself, and I will just explain you the basic concepts around something called linear programming, which is basic form of optimization. And just first thing is, I just want to remind you that optimization is really hard. And this is the example that will show you how hard optimization is. So the first thing, it tricks the intuition. So you think you can handle this, but you are not. And the example is, for example, imagine those are 10 guests. You are making a party, and you are inviting 10 guests to, and you've got one table right here, one table here, and so you just use your intuition. You just sit those guests around, and then if I ask a question to non-engineering guys, so what do you think? How many possibilities? How many? In how many ways you can place those 10 guests around one table? So people are answering the number like 50 or 100 or stuff like this, and this is 10 factorial. This is 10 factorial, and this is huge number. If I give you 10 factorial from the browser, from the calculator, it's 3.6 million of possibilities. So have you thought about that? And that's really, that's the power of optimization, and that's why optimization is so hard. And that's why, for example, different companies are creating the vaccines, and each one is different, but they cannot explore all the spectrum. They can just, of course, they are having scientific ways. However, they are just exploring the small part of the spectrum, right? And as we know, as you can imagine, if you know all the possibilities for placing 10 guests of yours at the table, then you know for sure that it is hard to compute. It is super hard to compute, right? So using decision optimization from IBM is, we've got those free libraries. You can use it for free. And when the model is getting complex, then we've got also the paid solutions that will let you going through this hardness of of computing everything. And it's really sometimes super important, especially in the company, to have to know all the options, not just the options that your intuition is giving you, right? So if you base on, or of course, I love my intuition. I'm using it all the time. However, like in the business decisions, if you're using only your intuition alone, you are like this guy searching for some object in the dark room, right? We just so that's very narrow comparing to what you can have. All right, so basic concepts in optimization are, the first concept is linear programming. So it's programming, but the linear programming was created in I believe in 70s or 60s. Sorry for not having the exact date. However, then it was, the programming meant more planning, because right now we've got plenty of programmers, meaning coders, people like me, for example, coding stuff, creating stuff, putting it on the GitHub and so on. So what here linear programming is like, it's like a planning more, and this is a way to having few variables. Like you've got, for example, those workers, and you've got some limitations that they cannot work all the time, 24/7. They need to rest, for example. They have some different focus on some different tasks, right? And then you've got those limitations, and you create a model where that has those limitations in it. I will show you this on the first use case. And then something that is used in the linear programming is called simplex algorithm. So I will be not explaining the simplex algorithm. All you need to know is that you, for the starter session, is just that it's this algorithm. When you go, when you give all those limitations, then the simplex algorithm will look for optimal mixture of some things, provided your function, if you're maximizing the profit or if you're minimizing the time, stuff like this, then the simplex is just doing this for you. And there are three things. There are decision variables, constraints, and objective functions. So decision variables is something you can move. So you can move with for example, the number of workers, or you can. It depends on you how much you put in, right? Then there are those constraints, like your worker cannot work 24/7. And then there's objective function, like minimize the cost, something like this. So for linear programming, it's this method to achieve best outcome, and this is also a mathematical model. But fear not, I promise to not go in too deeply. So those are nice pictures to just have the right intuition, because imagine that you've got two variables like x and y, and then you've got those limitations. So here are the limitations, and then you've got this objective function with this arrow, right? So for this arrow, this point is optimal, right? So this is for two variables. For three variables, this is like an object, and the simplex algorithm is following the objective function, for example, the max profit, on the edges of those walls, let's say, right? And then there are four variables, and I cannot tell you how this works. I can't give you visualization. However, simplex algorithm is doing this for us, and you can have like 100 variables or 200 variables, and you can have complicated models for example, for a factory or for some scheduling workers and stuff like this, and the simplex is working there really great. Okay, so again, decision variables, something under your control. Objective function is some goal you want to achieve, and that's why you are using this decision optimization. And then you've got those constraints, like business rules, like physical laws, like this stuff. Okay, I'm just watching all the time. My watch, not to talk too much. I don't want to tell about this one. This one is also important when you create those limitations, and the goal is like here, for example. Then the simplex is not working, obviously, because limitations are here, and the objective function is here. So that's not feasible. So we've got situations where the created model is not feasible, and this one is feasible because we have closed space of limitations, and the goal is here in that direction. So we've got feasible solution. So putting this all together, so we will be creating decision variables, and we will be defining constraints and objective function. So those three concepts are really important, and I will just show you on two super simple exercises how to make it. Oh yeah, so there is this exercise. So before we jump to exercise, let me just show. Sorry, my GitHub page. So you can stay with me. You don't have to do this or do the hands-on. You can just stay with me because this is short workshop, and after that you can explore my GitHub site. So this is this site, and you've got those two workshops here. The first one is Watson Studio. So as I said, Watson Studio is the environment on IBM Cloud to play with data. And here in this workshop, you've got this you've got this preparation lap. So if you do the first lap, you will just register to IBM Cloud, which is super simple, and then you create the instance of Watson Studio, which is our environment where we build data, analyze data, do various things with data. Yeah, and then after you create this Watson's, you will have Watson Studio. The decision optimization is just one feature of Watson Studio. So then you will be able to get to another workshop and go to the labs. All right, so that's it. I just wanted to show you this small thing. This is not something the IBM has made. This is made by me, so simple static site. And going back to our use cases, let me explore the first use case. So right. So we've got a cakes eating competition, right? We've got Max, and he's in this pie eating contest, and the contest lasts for 1 hour, which is 60 minutes. And then Max has two options. So this is simple, super simple, as I promised, and I keep it simple. So the one option is torta, and the second option is apple pie, right? So let's say for torta, it takes 2 minutes to each one torta, and apple pie is quite bigger. They've got those big apple pies, so it takes 3 minutes to eat one apple pie, and then after eating each torta, Max is receiving 4 points. And for one apple pie, Max is receiving 5 points. So now we've got this simple example when you have got your, on purpose, I made that you've got those intuitions, what should be happening. However, we will just build a super simple model to show you how linear programming is working. So the step one is we are creating decision variables. So for this model is like tortas are one variable and apple pies are second variable. So this is like X and Y for us. And then we are determining the objective function. So we want to maximize points, right? Because this is a contest. We want the optimal maximal number of points, and this is 4 points for each torta and 5 points for each pie, and this is Z, our max objective function. And then we've got some constraints, and on the constraints part, this is the least intuitive. The least intuitive. Sometimes you just realize after creating the model that you've got just another constraint and you need to add this to the model. So here is the constraint that the 60 is the number of minutes, and 2 minutes for torta and 3 minutes for apple pie. It's cannot be greater than 60, right? So that's this inequation gives us some line on the two axis space. And then we've got those non-negativity constraints that where you cannot have you cannot have negative number of minutes, right? So that's X is always bigger than 0, and the same with Y. So now then you just, what we will do, I will show you in the code, we'll just use this magic of simplex algorithm, and then for those inputs, sorry, I need to move it. There will be a feasible solution, and this solution will be 120 points by eating only tortoise, right? So that's something we learn from linear programming. And right now, I'm going to jump to my Watson Studio and show you some code. Okay, so let me just open my IBM Cloud my IBM Cloud account, I will look for the instance of my Watson Studio. Oh, here it is. Okay, so right now I'm opening the Watson Studio. Maybe, guys, maybe 1 minute for if you haven't seen IBM Cloud, maybe I'll just go with new incognito IBM Cloud register. If you just type in IBM Cloud register, you will just get to sign up for IBM Cloud. If you want to do it right now, you just put your email, your password, you agree with the cookies, and then after the password, you just give your name, second name, and after clicking next, you get an email with verification, right? And you're ready to go. And you've got IBM Cloud account, the Lite plan. And on the Lite plan, you can do many things. You can start each service for free with no limitations. You cannot start two instances of the same service. Then you need to go you need to upgrade your account to pay as you go. However, going back to Watson Studio, so we are starting Watson Studio on IBM Cloud, and this is really we've got the highest points from Gartner recently, because Watson Studio is part of something called Cloud Pak for Data. So we've got in IBM we've got those cloud packs. So the pieces of software that can be installed everywhere on containers. And Watson Studio is this is the free version. We also have a paid version, which is way better. You can do really you can just address all the aspects of functioning of a small or medium or large company doing it on Cloud Pak for Data. All right. So now the most important concept in Watson Studio is project, right? So we've got those projects. So I am entering decision optimization project. I have created this earlier. And in each project, you've got those assets. So here are some data I have just uploaded into this project. Here are some models I have created, and here are the notebooks. So we are looking for Jupyter notebook called Cake Competition Problem or Cake Competition Contest, and and right now we are in the view mode because this is the page, right? So this is not our computer. So we are clicking edit, and right now this Jupyter notebook file is gaining the virtual machine to actually have this ability to run some code on some processor. Right? So this virtual machine is starting. This is 2 vCPU, 8 gigs of RAM, only for your Jupyter notebook. Nothing more. So on your computer, you've got this limitation. You've got everything on your computer. Here, you've got separated machine only for the Jupyter notebook. Also, you can utilize GPU and other things. Okay, so we've got this example of Cake Competition Problem. And now, what we are doing. So let me just for those of you not being the coders, I will just slip through it really quickly, getting only the high level concepts. So the first thing is we are using the Cplex. Cplex is the first library out there in the issued by the company, by IBM, to address optimization. And you can do your own models using Cplex. However, if you create large models, like the number of variables grows to 10, 20, and right now that optimization is really tricky and it's really hard to compute, then it's better to use our paid libraries and our paid solutions to get the result within reasonable time. So the second thing is that we are just encoding the decision variables, the limitations, and the goal into the code. So decision variables are here, and objective is here. And then we've got the limitations. So the limitation is like here, the 60 minutes. So I'm just really going quickly through this, because this is not a coding workshop. This is just for everyone to understand that this code performs this model. So let's just run the code. So what I did, I just ran this piece of code. So imported Cplex. Now I am going through decision variables, constraints, solving the problem. And in the simple prints, I have just this text that match the simple text that Max should eat 30 tortoise, and he's getting 120 points, right? So now let's change something. For example, here we've got those constraints. So there's the tortoise takes 2 minutes, apple pies to take 3 minutes. So let's for example equal the time of eating tortoise and pies, because the context changed. Pies are the same size as tortoise, and then we've got this change. And so with the right now I'm just running this, but in the production environments, you can have this automatically. If something changes, you've got different results. And so right now it's eating 20 tortoise, and you can count only, you can expect 100 points, right? This is so the algorithm has given us 99.99999, but it's only because it is dealing with continuum variables, and we can easily round it to 100. Let's spoil it even more with the objective. Let's say 7 points for apple pie, but 4 minutes for apple pie. So right now I just don't know what is happening, because I don't have this intuition, right? So I'm changing this. So now it's 15 pies and 105 points, right? So we can see that there, intentionally I gave you just small number of variables to see how it is going, and you can see that the input changes and then the output changes. So let's get to more complicated example. Yeah, the pasta factor example. So right now we have the complexity is growing a little bit, only a little bit, because the case is following, that we've got the pasta factor, right? And we've got 3 types of products. So the first one is kluski, the second one is capellini, and third one fettuccine. And for each product, we can make it in-house in our factory, which is and we are using. It costs us this much dollars, or we can outsource it to our partners, and then it's a little bit it's pricey. And this is demand. So demand is like 100 of pieces of kluski, 200 pieces of capellini, 300 pieces of fettuccine. So that's one complication. The second complication is that each product has flour and eggs, and it's using different amounts of flour and eggs, right? And then you can just use this simplex algorithm. And let's get to the notebook. I will just show you. I will just show you the code, because that's you have already heard about the basic steps. So we are opening the code. We are giving the virtual machine to this code. and then I will show you all the complexity, meaning that we've got products, right? And each product has some demand. So we, for example, need to produce 300 pieces of Kluski, right? And this is the cost, internal cost, external cost. Here is how much floor and eggs we've got in-house. And this one is how much is used for each product. So now it's also simple, right? I mean, this is something that you can think your brain thinks it can handle. However, there are various ways where it's, for example, for now, if I give you a super quick question, which of those should we produce only capellini, only fettuccine, only Kluski? So you don't know, because you don't know the end cost, right? So let's run through the code, and I'm just running it without explanation, because this is not the coding workshop. I'm solving the model, and in the end, I am getting this value here. So this is the cost of $2,290 for creating these numbers of the products, right? So now let's say we didn't have a demand for fettuccine. Now we have super demand for fettuccine. What will change? How it will affect our optimal number of our minimum cost, let's say, right? Because the factory is something that wants to achieve the minimal cost. So based on those, we don't know. So that's why we are running the model, solving it, and then we've got the cost of 360, and we've got oh yeah. So now, sorry. So the model right now is saying that we should outsource everything. So let's look into the costs. Oh yeah, because I have set lately I have set the same cost in-house and outside the factory. So let's put some incentive or on producing things in-house. Yeah, and now let's check what the linear programming model is advising us. So right now, for example, I changed some cost a little bit, and now he's advising us to do the capellini, 50 pieces, and the rest outside, right? Also, this may be connected to our limited resources. So let's say we've got huge resources of floor and eggs, and now we are running model again, solving it, and oh, sorry, a few more steps. And now we've got totally different things, right? So we producing capellini, but we are also producing some of Kluski, right, in-house, and then we are giving everything to the outsource forces. All right, so that's the basic optimization in a nutshell, let's say. So I just wanted to show you that this is really something you could get the results quite quickly. Of course, what you need, and what is the most important and hard part, you need one guy in your company to get the knowledge how to build those models, right? And this is when you've got this, then you really need to can plan some things with optimal with the power of optimization, let's say.